Bonjour, bonjour, good morning. Okay, solution 3, question 3. I'm not going to do all the solutions, this is the last one. The other solutions are going to provide a mark scheme for you. Let's have a look, here are the questions. So question 3 is actually a graph question, and the first part is the plot of the graph. So by the magic of video, here we go, we have the graph. Let me talk you through a few features here that are really, really important, okay? Across the bottom here, look at the scale, look at the scale. I have not used their increments of 60. I've gone up in hundreds. I'm using a proper numerical scale there, and it covers at least half of the available space. I'm going to be plotting up to 300, so that's a winner. Units time slash quantity time slash units seconds. Okay, that's the convention for doing that. The y-axis, I haven't started at 0 because that would be silly. I've started at 80 and I've gone up in 2s all the way up to 38. So, 38. And once again, look, quantity, temperature slash units degrees C. That's the convention. No title required. I don't know where that myth comes from. Points plotted fairly accurately, I would say, even with my poor eyesight. I don't know if you can see on the video there, but I've tried to make the cross no bigger really than one of the smallest squares on the graph paper. If it's any bigger, you won't get marks for it. And I've plotted these points, and I've used by eye, I've estimated a best fit line, which just happens to intercept just there. If I was doing this properly, I'd use a computer and use a statistical model. If I was doing this for a CPAT practical, I'd take probably 2 gradients, a best and a worst, and do some sort of average. Right, so gradient, clearly show your gradient. I've drawn it on there. This is my delta y, okay, and that comes out to be 17.4 degrees C. This is my delta x, and I've clearly drawn a line there and clearly labeled it. Okay, do show on your graph or in your workings your gradient. And I've actually calculated the gradient to be 17.4 over 300, and it gives me this result here. Now, the mark scheme says it's plus or minus 0.004, so I'm well within, oh sorry, the actual figure. The actual figure they get is 0.056 plus or minus 0.004, so I'm well within there, okay? So that's the ideal answer that the exam board say, and this, I'm well within that, so that's good. I've got full marks on that, okay? Right, on to the next part of the question. So it tells us that the heater provides a power of 48 watts. So let's write that down. Let's write down power is 48 watts. It'll help if you can see me on the camera here. There we go. So the power is 48 watts. Now this is the power that's being delivered to that glass block, okay? And it's asking you to find the specific heat capacity of that block, right? Always write down our equation first of all. We know that Q is equal to MC delta theta. Now, we do not know what delta theta is, okay? But from our gradient that we've just calculated, our gradient was equal to 0.058. It could be used degrees, so I'm going to use Kelvin per second. What is that? What you've actually found out in your gradient is the rate of change of temperature, d theta dq, sorry, d theta dt, okay? This is the power that was given to it. That power is the rate of supply of energy. So that, in fact, is dq dt. Okay, that's what that is, and that's what that is. So how could we make this into a formula? So here we go. Let's divide by dt. So the rate of change of energy supplied is equal to m, which was a constant, c, which is a constant, multiplied by the rate of change of temperature. Okay, That's pretty nifty. That's pretty clever. And this is quite a high order sort of question, which requires you an understanding of what's actually physically happening there. Okay, so have a think about that. And then simply we can just plug in our numbers because we know all of that is equal to 0.058. We know all of that is equal to 48. I'm not going to rearrange this too much. So I'm just going to say that 48 is equal to, what was the mass? The mass was 1 kilogram times by C times by all of this, 58. So C is equal to 48 divided by 0.058, which comes out to be, I've already calculated it, 300,000. No, it's not. Wrong calculation. That comes out to be 828 joules per kilogram per Kelvin. Okay. Now I've used my value of gradient. Now, if you completely messed up that in an exam, that value for gradient, I wonder why this is not working. There you go. Is that a bit clearer? If you messed that value, the error would be carried forward, so you would still get some credit for this part of the calculation. And in fact, their answer, I haven't got it to hand right now, but their answer said something like plus or minus 60, and their value was something like 840, I believe it was. You can check it in the mark scheme, which is later on. So that's not too bad. Okay, so moving on. Okay, and the final part of this question is possibly the easiest. It's saying the heater is switched on for 200 seconds and 32 grams of ice melts. Okay, first of all, let's just recall, and let's get a camera up, the magic camera, yay. Right, let's just recall what the power of that heater is. Its power is 48 watts. Okay, so we need to remember that from previous. And it's heating up some ice, and it's asking for the specific latent heat of fusion. So our formula is Q equals mL. Okay, we're looking for L. We don't know what that is, so that's going to be M over Q. Okay, this is our formula. Is it? No, it's not. Schoolboy error. Let's get this right. L is equal to Q over M. That's better. Gosh, I haven't had my coffee this morning. Right, so let's have a think. So what is the energy supplied? The energy supplied is going to be the power times by the time, 48 times by 200 seconds, was it? 200 seconds, that's that. And we know the mass is 32 grams or 0.032 kilograms. Remember, that's where they're trying to throw us out. And let's just bring it all in. So it's going to be 48 times by 200 divided by 0.032. Get your calculator out. I haven't got mine. Right. Do the number crunching, and you actually get an answer of, surprise, surprise, 300,000 joules per kilogram. Okay. Or 3 times 10 to the 5 joules per kilogram. And that's the expected value for ice melting. So that's possibly the simplest part of that question. Okay, so I'm going to shut up now. I'm going to move on in the next session to introducing some new material. Here are the answers for questions 4 and 5. Pause your video and have a look at those. Here are the answers for question 6. Pause your video. And number 7. Okay, so I'll be back with, I do believe, the gas laws. Very exciting. Okay, enjoy.